Greetings, ladies and gentlemen, and welcome to Sherlock Hour. For the next 8 or so days, we will be detectives. And so you will see that now we are, okay, I'll cut it out. I'm sorry. That's cringe. That's cringe. I gotta address it. That's cringe. I may bring it back on the last day for just a little bit, just so we can come full circle and it can be a really cool, like powerful moment. But no, that's cringe. But guys, today is the day that as geometry teachers, I really have to buckle down because I know there's going to be some real challenges. The challenge starts today, and that's the truth. We're going to be dealing with conditional statements, forming conclusions with these conditional statements, but we're also going to be applying some properties. And it's these properties right here that I want us to be very, very careful about. Because we talked yesterday about deductive reasoning, and that's just the ability to draw conclusions logically from given information. That's something that we did yesterday with the law of syllogism, along with the law of detachment. So that is what deductive reasoning is. Now, geometric proofs, these are a different beast. These are different. I'm running out of room. In fact, you could say they are built different. To use that awful athletic cliche, which is garbage. Guys, these are valid arguments where we use mathematical statements as proof that we are correctly deducing something. This is the proof. And then you can see the proof is the result of correct deductive reasoning. And so, guys, there's going to be 9 of these. Again, you can't see how many fingers that is. There are 9 of them. Now, I want you to stick with me because they're all a little bit different, and some of them are drastically different, but they start off simple enough. How about reflexive? When we think of reflex, we think of, like really quick, being able to see something. Well, reflexive is usually pretty easy to spot because all it says is that an item is equal to itself. So angle L is congruent to angle L. 18 equals 18. Line segment DH is equal to line segment DH. All reflexive says is that an item is equal to itself. Simple enough, right? Here's something that sometimes people get confused with, though, is the difference between reflexive and symmetric. Symmetric says that we can switch the left side and the right side, and it's still the same. So switch sides, still the same. So check it out. If A equals B, then, well, B equals A. If X plus 1 equals Q, then Q equals X plus 1. And if Z equals angle P, then angle P equals Z. Now, so far, not too bad, right? And really, on their own, these are not too complicated. But it's when we start to incorporate them with certain mathematical statements and situations that you really have to be careful and not get them confused. So how about we get into some actual mathematical operations here? I'm going to switch colors. We're going to go green here. Addition says we can add the same item from both sides of an equation. Okay. So if we have A equals B and C equals D, we can say A plus C, the first piece in each, would be equal to B plus D, the second piece in each. Because clearly, A and C, B and D, each of these individually are congruent, so adding them together would give us the same. In fact, you can think of it this way. Let's say A equals B was really 2 equals 2. And C equals D was really 3 equals 3. Well, that would give us 2 plus 3 is really 3, I'm sorry, is really 2 plus 3. Same thing, right? How about this one? A little bit simpler. If x minus 1 equals 7, then what can we say? Oh, x equals 8, because you can add 1. And finally, if AB minus CY equals BZ minus CY, then by adding CY to both sides, we know you're really getting AB equals BZ. Combining like terms here, whether numbers or variables. Okay, and guys, honestly, subtraction is the exact same way. A minus C equals B minus D. Same idea, 2 minus 3 is the same thing as 2 minus 3. If x plus 2 equals 19, then guess what? You can subtract 2 thanks to the law of subtraction, the property of subtraction. No, x equals 17. And if AB plus CY equals BZ plus CY, if you subtract CY from the left, then you have to do it to the right. Those cancel, you're left with AB equals BZ. So these two are pretty similar. You can say addition and subtraction are very similar. It just depends on what the situation is, whether we need to add or subtract. So on to the next page, yes. That's our first four. And hopefully you're feeling pretty okay about those. Let's look at the next two. And I'm going to switch colors again. Let's go multiplication and division. And again, these are not too dissimilar here. Check it out. It says we can multiply both sides of an equation. Again, both sides, because that's how we keep it balanced. Always balanced. An equation is always has to be balanced there. So check it out. If A equals B and C equals D, then naturally A times C equals B times D. If you have x being divided by 6 and that's equal to negative 2, we know that we can multiply by the denominator. But what you do to the left side, you have to do to the right. X equals negative 12. And how about this? I'm going to let you guys see if you can try that part. And then here's where it maybe get a little tricky for you. I want you to try these three right here. Go ahead and try these four for me, and let's see what you get. All right. I bet you guys were absolutely cash money on these three right here. Well, check out this one. It says we can divide both sides of an equation by the same item. Interesting. Can divide both sides of an equation by the same item. So if A equals B, let's think about it. If A is the same thing as B, and we know we have C, which of course is not 0 because you can't divide by 0, then what could we say about this in division terms? Oh, well then A divided by C will be the same thing as B divided by C. I had a feeling that one might mix you guys up a little bit. And honestly, I'm not going to waste y'all's time on distributive. We know what the distributive property says. It says we can remove the parentheses by multiplying all items on the inside by all items on the outside. You guys know this. You distribute, guess what happens? A times B, A times C, AB plus AC. Like I said, I'm not going to waste y'all's time. Go ahead and knock these out real quick. I won't talk about them. When we come back, we're going to talk about the final two that I'm a little bit more worried about. All right. Hopefully no sweat there. We're just distributing using this property to say that we can get rid of the parentheses by multiplying what's on the outside. Now, guys, these last two. Take a deep breath. This is where some of the challenge really is. When we're talking about the transitive property, sometimes I call this trans for short. We can abbreviate it like that. It says we can throw out any item that appears in two separate equations. The key here being appears in two separate equations. That means it's kind of reductive, and we can say that, well, really, we can make a conclusion without needing that there. So, for example, if A equals B and A equals C, what can we really say here thanks to the transitive property? A is showing up in both equations, and A is equal to both of these. Really, we can say, oh, B equals C. How about this one? If angle X equals angle T and angle T equals angle W, boom, boom, we can say, okay, angle X equals angle W. Next one. A lot of times you'll see me mark these out, by the way, if it's reductive. Once we know we're dealing with transitive. If X plus Y equals W and X plus Y equals Q, then what can we say? X and Y show up twice. We can say W is really equal to Q. And I want you guys to try these next three for me. Try these next three, and let's see what you guys are feeling here. Hey, were you able to go 3 for 3 here? X is repeat, so A plus B equaling X. If X is Q, A plus B is really just equaling Q. If angle 5 and 7 are the same, and angle 7 is 90, then angle 5 is really 90. And you can see the same thing here. Okay, last page we're going to do here before I turn you guys loose. Substitution, another big one. Our other big one here, guys. This one is very similar, but here's the key. This is not the same thing as transitive. I'll write this in red. Substitution is not the transitive property. They are not the same thing. Here's why. We can throw out any item that appears in two separate equations. That's similar, right? That's the same. But here's the key. We replace what we threw out with something else. And the only time we use this is if there is an operation. So adding, subtracting, multiplying, or dividing. That's the only time we can bust out substitution. So check it out. If A plus B equals 6, and we know B is really equal to C, then we could say, hey, A plus C is really equal to 6 also. How about if B plus C equals 87, and we know C is really 21 degrees, we can replace C with 21 degrees. So I'm going to let you guys try these last two. See what you guys got on those two. We go 2 for 2 there, guys? I hope so. We're just saying that we can replace what we throw out with something else. Now, the last set of properties are actually properties we saw way back in Algebra 1. These are all Algebra 1 properties. All three of them, 10, 11, and 12. We know the commutative property says that order with adding or multiplying doesn't matter. It doesn't matter what order you add or multiply two things in. Check it out. S plus U is the same thing as U plus S. Same thing with multiplying. X times Y, that's the same thing as Y times X. No difference there. The associative property. Sometimes we call this, we abbreviate this as assoc. Yes, I realize ASS is in there. Ha, 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 ha. So, I don't know what that was. So, associative property says that if you have three things being added or multiplied, its order still doesn't matter. So, order doesn't matter with three things. So if you have A plus B that we're doing first, then we add C to that, well, guess what? It's the same thing as doing B plus C first and then adding A. Same thing. And guess what? Works in multiplication too. A times B first and then multiplying C is the exact same thing as taking A and multiplying it after we've already multiplied B and C. Order does not matter there. Now, for the last one of my favorites, combining like terms. We call it CLT. And all that means is that if you have a statement and there are like terms in that statement, they can be combined together. Well, guess what? This also works for geo-like terms. How about angles? Let's say we have angle A, and it's being added to 10 of another angle A. So we have angle A plus 10 times angle A plus 7 times angle A. Well, these are all still angle A's. Let me do this in another color so it's not as oversaturated. So 1 of these plus 10 of those plus 7 of those, that's 18 angle A's. And here's where you guys take over. And this is where you're really going to have to buckle down. I'm going to do a couple of these with you. How about number 1? If 3x equals 6. Oh, then x is really 2. How did we do that? Oh, we divided by 3, didn't we? Guess what? That's the division property. How about number 4? Angle B will be equal to angle B. Oh, that's reflexive. One more. I'll do one more with you guys. How about if CE equals x and x equals EF? Oh, wait a minute. X is showing up twice there. Then we can say that CE is really EF. Oh, well, if we have the x repeating and it's equal to both these things, we're talking transitive property. Again, you could represent this as trans for short. Now, I'm not going to scare you here, guys, but I will tell you, I want us to knock out 1 through 26. Now, guys, I ain't playing with you. I want you to know this. I'm not playing. These are serious. And if you don't take this early section serious, this chapter will kick your butt. So, guys, our homework that we will do is 1 through 26. Onto the back page here. And again, you're not solving these. You're naming the property. Okay? You are stating the reason for each of the given statements. You're not solving. I'll stress that. Not solving. Okay. If you have any questions, guys, you know how to contact me. Best of luck.